Еве го, аз го имам стримът. Не, пусти го. Го пусти? Пусти го, да. Тест. Окей, може да идеш. На свек на канала от General. Не, готово, ти го пусти долу. Стримът е пущен веки? Да, пущен. Се слуша. Да, се слуша. Дечки, може да почуваме? Да. Окей. Тест. Сега го изгубих микрофонът. Тест? Не. Микрофонът го изключи. Ова аудио си изгуби. Тест. Се изгуби от... Технически проблеми. Тест? Не. Тест? Не. Тест? Зlatko, kaj tebe?
Тест. Всеки мене мислам дека го снима. Така? Тест.
Okay, a little bit of difficulties. So, hello everyone, welcome to CocoaHeads Meetup number 13. I'd like to thank you all for coming here with us for the first meetup of the new year. And also I would like to thank everyone who's watching on YouTube or who is gonna be watching this later on, because the video is gonna be saved. This is live stream, so this is just like a testing and prototyping, but I hope that we are gonna manage it and continue with it in the future. Also, I'd like to thank our sponsors and supporters who are sticking with us for the whole year and continuing with the contract and with the support. So it's Infinum and etc. And of course, Netaville for providing this place and KFC. For this meetup, we are going to have two topics that are going to be presented by Zlatko and Ivan. And also, we are going to spend some time with drinks, networking, some food, hanging out, etc. So first, I'd like to welcome Zlatko with the topic of swift observation. So welcome, Zlatko.
Thank you. Okay, you can hear me. Yeah, this is like testing in production with everything, with the stream. Okay, so my name is Zlatko. I work as an iOS engineer for like 15 years or something like that. And yeah, I mean, not sure if, I guess you've noticed, but I really became a fan of the Point Free guys, let's say recently in the last year and a half, 2 years. So today I'm going to present something from, of course, their series of videos. By the way, a small side note, I'm going to present from a video because Keynote had issues with the screen mirroring and everything, so it's going to be like play pause and yeah. Let's continue. So I'm going to stop here. As I said, this topic is part of the Point 3 Guys series of videos about observation. So they're talking about the past, the current observable framework that went out this summer, right? And we'll talk about some issues with the previous solution, with the current solution, and yeah, some fixes that they actually introduced. I'm gonna share a QR code of this series later on. You'll be able to scan it, and if you're interested, to watch them. So let's start with how it was before. Basically, observation was introduced with the first version of Swift, right? The point was that we needed a way to automatically detect whenever something is changed so that it can be redrawn on the screen via Swift UI. So first we will talk about state. So state is basically a property wrapper that detects changes on the property and it triggers automatic redraw of the view, therefore applying the new changes. This state is basically like, because it works with value types, which is the view itself, it still needs to hold some kind of a reference to the current state. So basically there is some magic happening behind the scenes where you set a state to a view for the first time. The next time it's not gonna set a new state, but it's just gonna observe the changes of this one. And even though you set it on the view itself, again, the state itself doesn't change. The view redraws. It is created again, but the state doesn't change. Okay, so let's continue with this. So there are a few problems with this. If we use the state within the view itself, you can't really. There are a few issues. For example, you can't really test or write a good unit test because the idea is that you need to separate the business logic from the view itself, so that if you want to write unit tests, right? Also, for example, yes, using addState as a property wrapper is good for something like, let's say in a button you want to keep a state where the view is pressed or not, whether the view is deactivated or not. But if you want something to send from outside, you can't use this property wrapper. And yes, if you want to fire a side effect, like, I don't know, a network call or anything like that, it's not going to work with this solution. So if we start to separate, I'm going to stop here. So if we separate, let's say, the business logic from the view itself, let's say we create a class which is some kind of a view model, right? And there is a side effect, like in this dummy example. There is a network call, and after the network call, you run update of the title on the main actor. Sure, but keep in mind that this is a naive solution, because if we still use here addState as a property wrapper, it's not going to work. Let me see. I think yes, this is not going to work. The problem is that this property wrapper only detects changes on the property itself. But if you use a reference type like class, even though something changes within the class, the reference itself doesn't change. So basically you will not perceive the change within the class itself, so that the system is notified to redraw the view based on the latest state. Of course, for that reason, this observed object was introduced. I'm gonna allow this to play it out. So basically, observed object is a new kind of property wrapper where there is a requirement on the property itself to implement the observable object protocol. And there you can set another property wrapper in each individual property that you want to observe within the class itself. So here now this would work, because if you change the title, this published will automatically send, if you know, basically object will change signal, let's say. And this then informs the system, Swift UI, to redraw itself. But with this, let's say, old system now, there are still issues. So I'm just gonna let this. Okay, so basically these are there are many issues for sure, but let's say this is the main of them. If you this marking of properties as published can lead to either over or under observation of a model. What does that mean? So for example, let's say with under observation, if you have a private property which is this timer task, but then you have, let's say, a computed property, first of all, you can't apply the published property wrapper on a computed property. So whenever, let's say, the timer task changes, let's say becomes nil, of course this property wrapper will change, right? But because you can't mark it as published, you have to mark your own private property as published, and then it becomes basically a mess of you're not sure what you should mark as published, what you shouldn't. There is also the other way of where basically just to be sure you will want to mark all the properties with published, but that means that, let's say, even if a property is not shown in that view, let's say it's hidden for some reason, and if it's marked with published, then that means that if you change this property in the background, it's gonna change, it's gonna send this object will change event, and it's gonna trigger a redraw of the view even though the view doesn't depend on it. And for example, if you have something that's being, let's say, refreshed multiple times a second, it might lead to, let's say, some performance issues where you refresh something that you don't even need to be refreshed on the screen. So basically, I don't want to hang around too much with observed object. Okay, another point that I wanted to point out with this. This is called nested observation, where you have, let's say, a feature within a feature, and then, let's say in this, again, dummy example, you're in the body itself, you're reaching into the model, which is the app model in this case. You're reaching into one of the features, into the title, and you just are interested in the count, nothing else. This doesn't work because, first of all, you would think that, yes, I need to mark my models as published, but for the same reason that state with the view model didn't work, these features from the previous example, if you remember, were classes, basically reference types. So if anything changes inside, let's say the title, the reference type itself, the reference doesn't change. So that means the feature doesn't change. That means that you don't know about this change and it's not going to be redrawn. So there is a solution for this, which looks like, I'm going to play it out so that it's kind of clear with everybody. Basically, you need to subscribe to the events coming from the first feature, which is object will change, implement a sync, and then you need to send your own object will change event. And of course, you need to take care of holding on to this sync basically in this cancellables bag set. And yeah, now you can see that this is becoming like a kind of a small nightmare. And keep in mind that this is only implemented for first feature. If you want to implement for the second feature, you'll need to do this same thing again, which started to become cumbersome, let's say. Okay, so I think now we can move to the new framework that was introduced this year, which is observation. I'm not sure, is anybody aware of observation as a framework? Did you watch WWDC this year? Test. You don't hear me here? Test. Okay. Again, do you know about the new observation framework that was introduced this year? Okay, apparently not. Yeah, so it was introduced, and basically this framework is trying to solve all of these issues that I mentioned before. Basically, the whole idea is, first of all, that this is a separate framework. So even though the main use case of this framework was for Swift UI, you can use it for other use cases as well. So let's see how this looks actually. So first of all, I'm going to show you how it used to look like. So we still have this observable object protocol conformance. We have the property wrappers and here and also here. But with this new observable framework, is it okay? No, it's not. Can you hear me like this?
Yes.
Right? Okay. Then I just want to point out that now observation becomes, let's say, a lot less taxing on you as a developer to think about, because all you need to do is import observation as a framework, and you need to mark your view model as observable, and you should be good to go. Basically, it works like magic. So observable is a macro. You know that macros were introduced this year as well. Basically, what macros allow you is to add a lot of code behind the scenes that you don't care about, you don't need to see. But still, you can expand macros within Xcode 15 and onward, and you can see what it adds as an additional code. So let's see what's hiding behind the observable macro. So basically, let's say this is the condensed view model. And if you right-click and expand macro in Xcode 15, you will see something like this, which is quite a lot of code. But yes, I don't want to, let's say, burden you with all of this code. The key things to remember here is that it adds this register, which is basically behind the scenes. It's like a whole blob of things that it remembers. That's it. And it adds this access and with mutation methods. You'll see later on how they are called, let's say. And it conforms this view model to the observable protocol behind the scenes. So this is something that you don't see. Let's continue, because it adds some additional macros. For example, this observation ignored means that it's going to be ignored by observation. But we want now to expand this observation tracked macro, and we'll just do that. What's important for you to remember here is that for each property, it automatically adds this observation chart macro, and that actually makes this property, if you have it like a normal property, it converts it to a computed property behind the scenes, and it adds an actual property which is the underscore of the title of that, of underscore name of that property. And what it does is when you get this property behind the scenes, it calls this access method that we saw previously. And when you set it, as you set a new version of this, it calls with mutation. So long story short, what happens is basically this registrar that we saw before takes note of who is accessing and who is accessing this particular property. And when anybody mutates this property, then it will basically check within its, let's say, list or dictionary. Whoever accessed this property, it's going to notify them afterwards so that automatically the view is redrawn. So there is a lot of magic happening behind the scenes, which actually it's not magic when you peer into it. So this is my point that I wanted to let's say transfer to you, that it's all that. Just takes note of who accesses this property, and when this property is modified, then it just notifies all of those, let's say, views. Okay, so now let's just talk about observation again, but let's say a summary of this, a short summary before we continue. So now observation allows you to just hold on to the model itself within the view by a simple let. Or if you want to hold it yourself, you can use addState as well here. And all you need to do is mark the class, the view model, with observable. There are a few problems though. I'm gonna move this here. So let's discuss about these problems. This is something that you need to be aware as engineers. Observable cannot be applied to value types. That means you cannot apply it to enums, you cannot apply it to structs. Problem is that that means that now when you model your model, you need to use classes instead of structs if you want to have fine-grained observation of your properties. For example, let's say I'm going to go back a bit. Let's say here. Within your view model, you have another, let's say, property which is a model for an employee. And let's say that this employee has something like 10 fields within it. So what are you going to use for that employee? Do you want to use structs or do you want to use classes? Because the whole point of Swift when it was introduced was that structs and actually value types becomes, let's say, citizens of first order, which meant that you can add methods, functions to structs, to value types, as well as you were able to add to classes before. A lot of times, oftentimes, you want to use structures to model, let's say, the employee, because I'm going to return now to this point. Value type structures have equatability and hashability built in. That means that when you write a unit test, and let's say you want to test whether a model changed, let's say some property within the employee changed, because value types have equatability built in, it's very easy to to basically check the first version of your employee, let's say, and the second one, compare them, are they same or not. That's not true for reference types, for classes. The problem with reference types is that because they not only hold pure data, they can also hold behavior. That means that you can have side effects within them. Let's say a class can hold the timer as well. That's a problem because let's say even if you try to implement equatable on a class, you can't be really sure what properties you want to use to define that this, let's say, class of employee is the same with the other one. Because if you have a timer within it, are you going to use that timer for the equatability calculation or not? So it's a lot more complicated, and that's the biggest problem, that when you use observable, and whenever, again, I'm going to return to this, whenever, let's say, any property within your employee changes, one of those 10, it's going to trigger redraw of the view. And again, we go back to, let's say, over observability in that regard. Bottom line is, sure, maybe tomorrow you'll not care too much about over observation, but keep in mind this, that if you see that your view is being redrawn really often, that might mean that some property somewhere within value type is being modified, that it's not even needed for the view, and it can cause to redraw the view itself. So I'm gonna continue from here. Yes, observation is iOS 17 only. So that means that, yeah, you can't use it if you need to support older versions of iOS, which of course oftentimes you need to. So there is basically a kind of a solution which is called perception. This is again basically a framework built in the likes of observation by the Point Free guys, but you can use it from iOS 13 and onward. So that means that even today you can drop support, or you can stop using observable object, and you can start using perception. There is one small exception. I'm not going to tell you this. Find it out yourself. It's not terrible. Basically, you need in the view to add an additional, let's say, wrapper around the view. That's it. That is it, actually. I'm just gonna leave it played out to the end, because this QR code is actually the link to the presentations that I mentioned at the start of this presentation, if you want to check it out. And yeah, I guess questions.
Okay, if anyone has a question, please use the mic.
Nobody uses observation.
Okay, I guess that's it.
Okay.
Okay, thanks Zlatko, thanks a lot. The next topic actually is about Open API generators, and the presenter is Ivan Mihalchev. So welcome Ivan on the scene.
Hello everyone, my name is Ivan and today I will talk about OpenAPI, OpenAPI generators and how they can help you with the networking in your iOS app. So first, what is OpenAPI? The OpenAPI initiative was formed with the goal to form a unique way, standardized way to document and describe APIs. Which will be vendor free and it can be used by anyone. How do they aim to do this? They formed a specification which is at first it was based on the Swagger specification, but it has since evolved. And that specification tells us how we can document our API to follow the OpenAPI standard. It's here on the official OpenAPI site. You can read the specification. We won't go through it because there's a lot of info. What's most important are the supported types, but what the specification is and how to follow it, you just need to create a simple JSON object, and you can either create a YAML file or a JSON file, whatever suits you, and just follow the specification, and in that way you can document your API. Then once you have that your API documented, what are the purpose of the talk, the OpenAPI generators? Their goal is to use this specification or the specification for your API and to use it to generate code for you, so you can use to call your server, and everything should work out of the box without any effort from your side. So for the presentation purposes, I have one simple API running. Let me just I guess I will need to open a new window. Let's test if it works. So what the API does is it has this, let me just make it bigger. Okay. It has this grid endpoint which takes query parameter name, and then it returns you a message with the grid. Pretty simple. So let me just check something. Okay. So let's. I prepared a dummy app which uses this API. The view, it's really not relevant. It has a view model. What's important about the view model, it relies on this greeting service to make the request to the server. The greeting service is just a protocol that defines one method, getGreet. It takes the name parameter and returns a string. That would be the message that we receive from the server. So first of all, I've created this simple implementation of one possible way. How would you do this using NSURL? I mean URL session, not NSURL session. We need to define the model, some possible errors, and then URL components to create the URL, add the query parameter, and then make the request, decode it with the JSON decoder, and then return the response. As you imagine, this will get more complex if you have more endpoints that need to handle more stuff. But let's just run this and see if it works. Okay, so we got our response. This works fine. Now let's see example of how we can use the OpenAPI specification to document this API that we are using at the moment. I have it prepared here. So first of all, what you need to do is specify the OpenAPI version that you're going to use. Then some info about your API, the title, the version. And after that, you specify the servers. You can specify multiple servers here, for example, for different environments that you're going to use in your app. And after that, you specify all the paths. Basically, these are your endpoints that you define here for your API. Currently, we have just this grid endpoint. That's a GET request. We have an ID for the operation. It takes only one parameter, which is the name. It's not required, but it can be, doesn't matter. It's a query parameter. And yeah, it's a type string. And also we define what response should we expect from this endpoint. Also, you can leave it void if you don't expect any response. So for this call, we expect 200 success response, which will be with the content application JSON. And for the model that we expect from the server, we are defining this greeting schema. And to define how this model would look like, you add this components part here, where you specify your schemas. These are basically your models that you are going to use to decode your response. This is a greeting model that is an object, and it has one property, message of type string, which is required. So this is it. This is how how we can describe this API using the OpenAPI specification. And once we have this, we can use it to generate some code that can help us with our API calls. For this demo, I will showcase two generators. The first one is this OpenAPI generator that is open source project. It has a large community that supports it, and it's pretty simple to install. You can just use brew, and that's it. You will have it. It supports a lot of platforms, and also it supports a lot of languages. So not just Swift. You can use it to generate a whole network layer for whichever language you want, basically. Now let's see what do we need to use this generator to generate our network layer. First of all, we would need the OpenAPI specification for the API that I showed previously, and also you need to configure the generator so it will know how to work. As an example, I have this configuration. This is not important for the time being, but what we have here is we specify the name of the generator. We want to use the Swift 5 generator because we want the code to be generated in Swift. We have some properties. These are not really important. I just disabled the documentation. You will probably need it if you do this in production. We also have some additional properties, is to add some namespacing and file structures in the code that will be generated. This will generate an SPM package, so it's really easy to integrate in your projects. And also here you have the option to specify how do you want to use the API. Basically, here I have specified a sync await, which means that it will use Swift concurrency, but you can specify combine or whatever you want, depending on your needs. So once you have the configuration and the API specification, You can use this to generate your code. So let's try it out. So to generate your package, you would need the OpenAPI generator tool and the generate command, which accepts the OpenAPI specification file. We need to specify the output location for our package, and also the configuration for the generator itself. This is it, basically. So when we run this command, we get an error. Not sure why. Okay, I'm not in the right folder. Let me try again. So now it worked. Okay, now we should be able to see our package. Here it is. And to use this, we can just simply drag and drop it to our project. As you can see, it has one dependency that is already fetched. And also, because we just drag and dropped it, we need to add it in our framework libraries and embedded content. Here it is. Now let's see what this generator generated for us. Here is the package. What's important to you, it's located here in the sources directory. Here is all of these files is just the network layer, and remember here you have implementation for everything that supports all HTTP requests, file downloads, uploads, whatever you want. And what's important to us here is this APIs. This is just our default API that was specified in the specification. This is what we will use to make our network call. And here we have the models. If you remember, we specified a return type, which is a greeting model, and here it's generated for us automatically. So let's see how we can use this to simplify our networking call. I will create a new implementation of the greeting service. Let's call it greeting service open API. And here, what we need to do is first import our package, which is called OpenAPI client. You can change the name in the configuration to whatever suits you. So let's try to use it. Greeting service, and we need to implement this getGreet method. So how we can use this generated API? We just call it like this. OpenAPI client, the default API, and then get greeting with a name. And here we just pass our name. And since this get greeting returns the greeting model, and we want just the message, we will just take the message. And this should be it, and this should work. So to test it out, let's just switch our implementation to this new one and try to run the app. Okay, let's test it out. And as we can see, it works perfectly fine, just as before. We just now simplified everything. I mean, It has everything that's necessary in the background, but the only thing we needed to write was this piece of code. This generator has a lot of configuration options. It has, you can read the documentation, and you can see everything there. You can configure it to generate the models or the network layer in whichever way you want, because it has some templating model in the background, and you can modify those templates to meet your needs. So yeah, this is it for the for this open source Open API generator. Next thing that I want to show you is starting this year, Apple introduced their own Open API generator, and let's see how it works. To use that, we need to add a couple of packages that are provided by Apple. So the first one would be this Swift Open API generator. This is the main thing. This is basically the generator that would generate the code. It has a couple of dependencies. And for this one, we don't need to add it to our target because it's just a plugin that it will generate the code during build time. So we just add it like that. And after that, this relies on a runtime that we use to basically the runtime declares some transportation protocols that we need to implement to use this code that will be generated by the Open API generator. But Apple was kind enough to provide an implementation for that that uses URL session. So let's first add this the runtime package. And for this one, you need to add it to your target because you will use it in your code. Okay, that's done. So now we just need to add the one implementation of this, which is provided also by Apple, and it's relying on URL session in the background. Okay, let's add that as well. So once you have all the packages, there are also 2 config files that you need to use this Apple generator. The first one would be, of course, the specification for your API. This is the same as before, so nothing to discuss here. And also there is a configuration for this generator as well, but it's much simpler and doesn't have too many options. Here we just specify that we want the types, which means the models, and also the client to be generated. Once we have the config files, we just need to add the plugin. That's the Open API generator, which is provided by by this package here, the Open API generator. We add it here. Here it is. And what this will do, it will run on build time, and it will generate all the code that you need to make the API calls. So first, we just need to make sure that we have a successful build. And if the build is successful, that would mean that the code is generated. Okay, so we have a successful build, which means the code was generated, but it was generated in build time, and it's not that user-friendly as the previous one. You can just inspect the files. It's not, as I said, it's not that user-friendly. You need to know what you're doing. So what I will try to do is create a new implementation that will use the code that was generated by this generator. Uh, let's call it greeting service Apple Open API. Not the best name, but just for demonstration purposes. And here we need to import the runtime package that was added previously. We need that to execute our network call. And let's implement the greeting service again. To use the code that was generated by this generator, first we need to create a client. As we can see, it's available. We need to get a server. We'll just get the server one. And by the way, this server here is the server that was specified here. So if you have specified multiple servers, they will all be available when you through these servers. And also we need that transportation layer implementation that was provided here by the Open API URL session package. Let's just add an instance here. Just try to find it. Open API URL session, or not sure, URL session. Yeah, this is it. Okay, now we have it. So here you can technically create your own implementation of the transport layer, and you can use that, but this works perfectly fine, and it's easily extendable, and you can add your own features in it, so it's a good starting point. Next, what you want to do is use this client to make the API call and get the response. To do that, we can try to call this get greeting, and we need to specify a query. So this is not as user-friendly as the previous one. Apple have made it this way, not sure why, but you need to specify a query which initializes some query parameters, and for our case it's just the name parameter. And after that we can try to take the OK response, and we can get the body from it and the JSON, and then we can get our message. It's a bit confusing, so yeah, I forgot the await. We can inspect it, and here we can see how our model was generated. So we have this enum that's called schemas, and here all the models that were specified in our specification will be generated like this. We only have this message, which has this message property, and that's it, just the coding case, so you can use it to decode the response. Okay, so this should be it. This should run fine now. Let's just switch to implementation and test it out. as we can see, again, it works perfectly fine. So it was successful. If I have to compare these two generators, I would say that the first one is much better at the moment because it has a lot of options and you can extend it however you want. You can customize it, and it's much easier to configure to work with multiple APIs specified. For this one, for the second one, I couldn't find a way to specify multiple API specifications, for example, and it's not that mature. It just came out this year. The good thing is that it's provided by Apple, so we should expect it to grow and to improve in the future, but for now I would stick to the open source generator. One thing that, for example, I can mention, because we had this problem on our project. We wanted to do a custom mapping, so we wanted to generate, for example, when the type was in the specification was specified as a number and the format as a decimal, we wanted to generate it to the decimal type. By default, this would be generated as a float, but we want it as a decimal, so we could easily do that here by just specifying the type mappings. You can also specify a custom type here, so you can generate your own custom types, which is not possible at the moment with the generator that is provided by Apple. At least I couldn't find a way to do it. I guess that's it for my presentation or demo here. If you have any questions, now is the time.
Thank you, Ivan. Questions? Anybody? I have one if nobody wants. Okay, I want to ask you this, actually, let's say from the Apple framework, the Apple solution. You said that this is being generated during build time, right?
Yes.
How much does it slow down build time? Or first of all, does it execute every build? Or there is some kind of a smart logic behind it so that it detects now I shouldn't rebuild the whole?
Yeah, probably there is caching and there is a mechanism to detect if there is a change in the specification, so it won't generate it all the time. And I'm not sure how, I mean, here it's pretty fast because it's just a simple API, so I'm not sure how it will behave with large APIs. It would take for sure some time.
Yeah, that's my question.
There is another option as well. You can add it to a package. You can create a package that will add the generator there as a plugin, but then again, it's the same thing because you will need to build the package, and it's maybe easier just for distribution.
Yeah, that's my point, that
Yeah.
If you have a separate package and you build it manually yourself, you'll build it when you need it, and
Yeah,
otherwise it might slow down build times.
it might, yes,
Yeah,
for sure.
That's my concern, let's say. Anybody else? Or okay, I don't see. Yeah, thank you, Ivan. So I'm gonna
Thank you, everyone.
close this event.